In this presentation, we're going to talk about the role of theory in social research. Empirical social research is really based on two things: observations and explanations for those observations. And we can have various sorts of observations, including direct observations or indirect observations. Direct observations are those in which you are actually collecting data about society. You are making those observations. You are talking to people. You are asking people questions. You are surveying people. You are running experiments with people. Indirect observations are those in which others have observed society, others have collected the data, others have interviewed people, others have engaged in ethnographies, and they've reported that information and provided you with all of those data for your own analysis. So it's indirect in that others have done the observations and you're just analyzing those data. Explanation is the other part of that. Explanations are theories or reasons for the patterns that you see in those observations. You notice that after you've interviewed 100, 200, 300 people, people of a certain age tend to vote a certain way, and you can start identifying those patterns, saying, okay, people who are over 65 years old tend to support this kind of candidate. People who are between 18 and 30 tend to support this kind of candidate. Explanation part of that is coming up with a reason why younger people tend to vote for one candidate and older people tend to vote for another candidate. That's what we call a theory. Theory, based on prior research, is an explanation for the relationships between variables and patterns we observe. So we're looking at a bunch of observations, we're figuring out what those patterns are, we're interested in certain kinds of variables. In that earlier example, one variable is age, and then other one's political affiliation. So we have political affiliation as one variable, we have age as another variable, and we're trying to come up with an explanation for those patterns across these variables. We can build theory in various ways. We have deductive versus inductive theory. Deductive really starts with the literature. What does the literature say about the relationship between age and political affiliation? A deductive model starts with literature, using their theories, and then applies it to data. Inductive theory is something we call bottom-up or data-driven theory construction. It's really thinking about what relationships you're interested in, not really wedding yourself to one particular argument, just saying, okay, what have various people said about this relationship between age and political affiliation? Then you take those ideas, those notions, into the field with you. So some say that older people support Republicans, some say older people support Democrats. You take all of these notions into mind when you hit the field, and then you go out in the field, you start collecting data, and you start identifying patterns. So again, while you're not wed to a specific argument or a specific theory about what's going on, you say, I'm going to let the data tell me what the theory is. You see this a lot in qualitative work. You have a notion about what's going on, you enter the field, you start interviewing people, and then you start letting the data tell the story. You can identify patterns based on what the data are telling you, what the data say. A lot of quantitative work actually benefits from the inductive model as well. I think the old school model of research is you start with a theory that's based on literature, and then you go into the field and try to prove or disprove it. Whereas more contemporary ways of approaching research is saying, okay, we know what the various arguments are, let's go to the field, let's gather some data and see what do the data say. It's really up to you on how you want to approach theory building. Here's another example of models of theory building. The deductive approach starts with a developed research question. You read the research on the relationship between the variables, then you develop a theory and hypotheses based on your research. You collect data, and then you analyze those data to test the theory. So we see that in this left module here. We say you begin with a hypothesis that says hours of studying is related to grades. And we see it's a positive linear relationship. As hours of studying goes up, their grades too go up. So a theory would say the more time spent studying, the higher one's grades should be. And we see somebody who's only spent 10 hours a week studying should only expect to get 25%. Somebody spent 20 hours a week studying, they should only expect to get maybe 40% in the class. It's a straight line linear relationship. So that's your theory. Then you go out with your theory, collect some observations, and you say, well, it's not really straight line. We see some people spend more time, between 20 and 30 hours studying, and they still get low grades. You have some people who may spend 10 hours a week studying and get a 50, which is the same as somebody spending 20 hours. So it's not really a linear relationship. Then that model of theory building suggests that we look and compare our hypothesis or our argument with the actual data And one could say that yes, in some instances, these specific hypotheses fit the data. It fits here, it fits there, it fits there, it fits there. However, what about these cases where the theory says one thing, the theory is the red line, but the observations, the yellow, say something different? So that's the deductive model. Inductive would begin with a research question saying, hey, I think that hours spent studying might be related to someone's grade. So you read the research on that relationship, but you don't develop a strong argument. You don't come up with hypotheses, but you just know that hours studying and grades are the variables you're interested in. Then you go out, you collect your data, you analyze your data, and then you develop a theory that explains those data. So here we begin with an idea, a notion, not necessarily hypotheses or theory, but we go and we collect the data, we see this curvilinear pattern, and then we say, okay, what is the conclusion? Why would we find a relationship like this? And there you're developing your argument, your theory, based on what you found in the data. One would be a linear deductive model. The other one says it's more adaptive to what the data suggest. Finally, this is just an example again of the traditional model of science. We say, what causes why? Well, we have a theoretical understanding of what causes why. We lead to a theoretical expectation, we develop hypotheses, and then we start collecting data, go through observations. But again, that may not be the way that things operate nowadays, but this was the traditional model of science for many years.